So how do you define inverter? The converter which converts DC into AC is called inverter. So this is like, there is a box, it's an inverter, the input is DC and the output is AC. AC means, I can say, symmetrical, right? Or symmetrical AC, whatever it is. So what about the inverter gain? Inverter gain is nothing but output AC by input DC. That is the gain of the inverter. Okay. Now if I consider an ideal inverter, so ideal inverter, this side only, ideal inverter should be the pure may not be pure DC input, but it should give a pure sinusoidal output. That is the ideal. Yes, answer is C only. Answer is C. It can be turned on, but it cannot be turned off with a gate pulse. Answer is C. Earlier question. Okay. So this is a pure sinusoidal. It may be or may not be at DC. What about the practical inverter? The practical inverter, how it be? The practical inverter, the output may be, not maybe, it is a, definitely it is a non-sinusoidal. That means sinusoidal plus harmonics. These harmonics are making as a non-sinusoidal. This is a DC, this is a output non-sinusoidal. Now if you see pure sinusoidal, it looks like this, right? This is a signal which is not at all possible practically, because it might not be this much smooth. It might be because, say, at this instant the value will be here, the next instant the value will be here. Or I can say this is a continuous time, but if you see the discrete time, how it looks like? This is the sinusoidal, right? This is the practical, but the one which I have drawn is continuous, that is not the practical value, right? Now this is a pure sinusoidal. It might not be exactly this from this. How the output of a inverter? It looks like What are all these things? These are all switching instants. So when you switch on one device, the output voltage is like this. When you switch on other device, it is like this. So this is, it may be pure sinusoidal. So in this case, the switching frequency is high, because in a very small time you are doing so many number of times you are making switch on and switch off the device. For example, if you make switching frequency is very low, so how the output will be? The output will be like this. Right? So this is the output which is having less switching frequency. So this is not a pure sinusoidal, this is a non-sinusoidal. This is a almost sinusoidal. So this non-sinusoidal you can represent with a pure sinusoidal plus harmonics. Okay? So what I can say, if the switching frequency is high, this is almost sinusoidal. This means harmonics are less. Non-sinusoidal means harmonics are. So what I can say? If the switching frequency of the device or if the switching frequency of the inverter is very high, then you may get almost sinusoidal. So, but in case of a DC to DC converters, the reason why we go for high frequency is to reduce the size. But here, to get the pure sinusoidal waveform. So, inverters should operate at very high switching frequencies so that the output is having less harmonics. This implies almost sine wave. So F is high. What does it mean? It has to on and off within small time. That means on time comma off time is small. This means unit switches are fast acting switches. So this is the application where you require more frequency. You require more switching frequency. Yes. Applications. These are widely used in industrial applications. Industrial applications means variable speed drives and UPS. What is UPS? Uninterruptible power supply. Next, types of inverters. Types. You are having basically two types, single phase and three phase. In single phase you have half wave, full wave. Sometimes this is also called half bridge. This is a full bridge. Here also same thing. Half wave, full wave. Now, what kind of technique that they are using in inverters in order to get sinusoidal output voltages? That kind of technique that they are using in inverters is called pulse width modulation technique. Pulse width modulation. I'll call it PMW technique used in inverters to get sinusoidal output. We'll see all kinds of pulse width modulation techniques separately. Okay. As of now, we'll discuss single phase inverters, and then three phase. Then we'll go for pulse width modulation techniques. So all this inverter is nothing but simply single phase, three phase, and pulse width modulation techniques. That's all. Okay. And one more classification is there. Classification of inverters. Based on input quantity. Because I told you it is input is a DC. So type of input quantity. So how many types? Because the input DC may be voltage or current, right? So this is voltage source inverters and this is current source inverters. What is the VSI means? Voltage source inverters, and this is a current source inverters. Mostly in our gate syllabus, mostly it is a voltage source converters. So how do you define this? It's like where is the input is voltage and the output is whatever it is. This is a VDC, and in current source you will be having a constant current. There is the output. Okay, this is VSI, CSI. No, I think this is wrong. This is inverter, that's all. This is an inverter. The inverter which is having a DC, this is the whole setup is VSI. This is also inverter which is having input as current is a current source inverter. Okay.